Alrighty. Anybody confident enough in their answers to the first one to tell me what you think you got? Yes.
I got 2.65 for the y0, the original height.
Okay. And then the velocity?
Also 2.6.
Okay. So one of them's right. One of them is not quite. We'll go over that together, though. Anybody get a different answer for the height?
Yeah.
What'd you get?
11.
Okay. Yeah, that's more along the lines. So yeah, we'll go through that together. And before we do that, though, anybody want to take a guess as to why the Scarecrow got promoted?
Oh no. Without standing in the field.
Nice. Perfect. Right on the money. He was outstanding in his field, which works on several levels. So you should appreciate that.
You realize that we got 2 dad jokes today, one from Mr. Dr. Jensen and one from me now?
What was the one he told? I don't remember.
It was over the announcement. It wasn't good. I
Okay.
forget.
I don't remember it either. Well, here's the second one. So, lumberjacks really enjoy going on the internet. Any guesses as to why? Nope.
It's quite close.
It's not a play on timber.
Oh.
They just love logging in.
Can I get a pass?
No. Okay. No. Let's do the question, and then we'll do the examples, and then you'll have the rest of the hour to work on worksheet number 3. We've got 2 equations here. X equals vt and y equals y original plus v original t plus 1/2 at squared. There are 2 velocities, one in each of those equations. What are the differences between those 2 velocities? Anybody want to tell me one? Yes.
There are no differences?
Incorrect. Yes.
Different directions. One's in the X and one's in the Y.
Exactly. So this velocity right here, that is a horizontal velocity. Because it's a horizontal equation, you can tell it's a horizontal equation because there's an x there, and there's no acceleration in it. Horizontally, this object won't be accelerating. This one here is vertical because it's a y equation, and you've got your acceleration right there. And acceleration is just something that happens to objects vertically because gravity's pulling them down. Is there any other difference between these 2? You guys said the difficult one. What's the one that's a little bit more obvious? So don't think too hard.
One's at an angle?
Nope. So this one has a little O next to it, and that means original velocity. So this would be the original vertical velocity of this object. This does not have an original sign next to it. And the reason for that is because, I mean, number one, this velocity represents a final velocity. But if we're moving horizontally and there are no other forces acting, this velocity will be the same from beginning to end. It's not going to change. So this represents final and mostly consistent velocity. This one represents an original vertical velocity. So yeah, good job on that. Let's take a look at the questions then. So this was the first scenario. We've got an object that's rolling horizontally off a table. We want to find its velocity. We want to find its height. Which one should we go after first? What do you feel like? Let's do velocity first. So in order to get velocity, we got to find it in one of these equations. Should I use this equation to find velocity? No, why not? There is no original velocity. There's another reason, though. It's arguably more important. Yes?
That's vertical and this is for horizontal.
Yeah, this is a vertical equation on account of the acceleration that it's having here. So we're not concerned with that velocity. This one's not really going to help us either, because again, you know, this is a vertical equation. This isn't going to help us because it's a vertical equation. So x equals vt. So that horizontal velocity v is going to be distance over time. And holy moly, for a change, we've got both of those numbers. How about that? So our distance is 4, and our time is given, I gave it over there, it was 1.5 seconds. I'll just slide that in here. So yeah, using that information, we've got a velocity of 2.67 or so meters per second. And again, make sure, again, that you're thinking of this in terms of vertical and horizontal motion. This is a horizontal velocity we're looking for. Therefore, this distance that we're using has to be a horizontal distance. If this gave us the height, that height would not go here because it's a horizontal distance that works with this equation. All right, in terms of the vertical height that we're looking for here, we've got a couple of options. This has vertical height. This has vertical height. I'm not going to use this one because I do not know what the final velocity is. So I would have 2 unknowns in this equation, and that wouldn't help me. But this equation looks like it could be a little bit more useful. Let's take a look. What's my final height going to be? 0. Yeah, it's going to hit the ground. So that's 0. The original height is what we're looking for. What is the original velocity? What's the original velocity here? Is it 2.67? Because that's the speed we're rolling off the table? No, because this is a horizontal velocity. This is a vertical equation. Vertically, this object is not moving when it leaves the table. It's just rolling horizontally. So vertically, this original velocity is nothing. Then we've got 1/2 at squared. Acceleration is negative 9.8. And then the t is 1.5. So, if we get this original height by itself, it would move over here, making it negative. That negative would cancel out with this negative. Therefore, our original height is 1/2 times negative times 9.8 is 4.9. And you'll get that height equaling about 11, I believe. So we've got our 2 answers then. What's the same? What's the same? I'm sorry.
It's just the same again.
Oh, as that. Yes.
Which was the same as the other one.
Yep, and that's the idea. So this problem leads into the next one. So now basically what we're doing is we're saying, okay, the height is 11 meters. The velocity is 2.67 meters per second. But now the object, instead of rolling off the table, is going to be launched at a 30-degree angle. And instead of taking that path, it'll go more like, and it's going to land a lot further away, but run out of room there. So this time is going to be different now. We're not going to know what the time is right away. So now the question is, how far is this object going to land from the start of the edge of the table there? So that's the main thing that we want to calculate in the second part. Anybody confident enough to share what they got for this answer? Nobody got it in the first physics class, so I'll be really impressed if you guys got it. Michael, yes?
The x equals 3.16.
I did not get that, but that's pretty close. That's pretty close. Sarah?
Wait, for the x, right?
Yeah, for the x.
Okay, I got 3.67. 2.794. just before.
That is right on the money. Very good. So let's go through this together. Before we do that, I want to fix this little thing here because I cannot deal with a trajectory that looks so crazy off.
Okay.
That's a little bit nicer. Okay. So step one, when you're figuring out how far away this object is going to land from where it began over here on the left, is figuring out what the different components are of the velocity in the x and y direction. So that velocity in the x direction would be like finding the horizontal component of the velocity here. We found the velocity was 2.67 in the last problem. So we got to figure out how much of that velocity is acting horizontally. And you can do that then with a cosine function, because this is the adjacent side. And when you do that, you should get 2.3. In the y direction, it's the same thing, except now you're using sine, because you're dealing with the opposite side. So that's step one. If you remember how we dealt with step two yesterday, you might remember that that's where we solved for how long this object has been in the air. Because if we want to solve for horizontal distance, we need both horizontal velocity, which we have now, and time. We don't have time. Hopefully there's a nice way to do that. And there is. The equation that you'd want to use for time is this one right here. You could use a combination of these two, but that would be several steps instead of just one. So the way we deal with this then is our final height is going to be 0 because it's going to hit the ground. Original height is 11. It starts 11 meters up. Original velocity, is this going to be 2.67? No, why not? Because 2.67 is the velocity in both the x and y direction. It's angled. But this is a vertical equation. So the only velocity that's going to go here is a vertical one. Yeah, so that's going to be 1.3. Very good. Oh, what happened?
Forgot about the negative, so now I got 3.8.
Yeah, that's better. Yep. So then we've got 1/2 at squared. Acceleration is negative 9.8, so I'll put the negative out here. 1/2 times 9.8 is 4.9. And look at that. We've got ourselves a quadratic.
God.
Oh, they're not too bad. So negative 4.9 would be your A, 1.3 would be your B, 11 would be your C, and when you plug all those in, you should end up with a time equal to 1.64. And now you're almost home free. If distance is equal to velocity times time, I know my horizontal velocity is 2.3. That will not change because there are no horizontal forces. And the time is 1.64. And that multiplication will get you that answer that I've been hearing, 3.78. So there you go. A little bit shorter way to do that problem that took most of the hour yesterday, huh? Questions on any steps here? Worksheet 3 is due on Thursday. Tomorrow is a Mythbusters Day. So feel free to help each other out on that worksheet. I'm also here if you'd like my assistance.